This tutorial extends the idea of line fitting to quadratic curve fitting. So it's potentially y is equal to a plus bx, which is the linear part, plus cx squared, which is the curvature part or parabola part in a curve. So let's take the example of the same data that we had in the linear case, and let's plot it as circles. So now previously we passed a straight line, now we want to pass a curve, and in this case also the same idea applies, but now our A matrix has 1, x, and x square in each row. So as you can see, x values are 2, 3, 5, 7, 9. So for the x value of 2, we have 1, 2, and 2 squared. For 3, we have 1, 3, and 3 squared, so on and so forth. So our A matrix now is n by 3 matrix. The same idea applies. We can find a pseudo inverse of this matrix, which is A transpose A, and then we take the inverse of that and then multiply it with the A transpose, and then we multiply that with the y column that we already have here to get the parameters, and we will get 3 parameters in this case, which are the values of A, B, and C. Now once we have the parameters, we can multiply that with the A matrix to find the value of the y estimate or y fit, and I'm going to use this square bracket to put these y and y fit values side by side, and you can see that these are the observations and these are the values that the model fit showed, and you can even add y minus y fit to see what the errors are. Y fit to see what the errors are. So these are the errors, and the squared of these errors summed together is what has been minimized through this process. So in order to see this quadratic function, we can define a function of x by using the P1, P2, P3, which correspond to A, B, and C in the equation A plus BX plus CX squared. So that's our function f, and now we can plot all of these things on a single plot. So we have the plot of the observations, plot of the fit. So these are blue circles are our observations, red X's are the model fit, and then it will be shown on top with a curve, which is our function f. And here you can see how this process has fit a quadratic line through the data points. And if you compare this with your previous model, linear model fit, you can see that this is much more accurate than the other one. You can actually estimate the squared error in both cases and compare which model gave you the least squared error.